Alrighty, hope you're just about as excited as I am to do some more proofs today. We're going to start off with a proof, just to review a little bit. Now we did learn the other day about side congruence, which says if three sides of one triangle are congruent to three sides of another, then we have congruent triangles. So far, that's all we've learned, at least as far as showing triangles are congruent. So that's going to be a goal on this one. We will start with our givens. So we have lots of them. BC is congruent to segment AE. And let's mark these as we go. So BC here, AE there. Got it. We already got one side taken care of. Then our next given, and we're going to combine these all into one. Segment BD is congruent to segment AD. And segment DC is congruent to segment DE. So we'll mark those as well. So DC and DE, BD, and AD. So those are our givens. Now the triangles trying to show are congruent are triangle ABC, which should be this one. Apparently I need to calibrate. So that blue one there. The other triangle is this one, BAE. So we're trying to show that those two, the blue and the green, are equal. Well, we have one side so far. We have two sides remaining. So again, step one, this was our given. Now you should notice that those two triangles share a side. They both share where they overlap, right? You can see they overlap at segment BA. So that's going to be segment BA is congruent to segment BA. And that is our reflexive property. Of congruence. So now I got one side left, or one pair of sides, and that's going to be to show that segment AC is congruent to segment BE. What we're going to have to use is segment addition, because that'll allow us to be able to write an equation that has AC in it, for example, because we can say AD plus DC equals AC. And we can say the same thing here. BD plus DE equals BE. And that's postulate 2, or segment addition postulate. And our goal, again, is to show that these two are the same. So if we can get, say, this chunk and this chunk to match, then we can say AC and BE are the same. So that's going to be the goal. And this is going to come in handy here. We're going to need to do some substitution. But before we can substitute, we have to change to equal. Because right now this is segment BC, for example, let's look at these. This is segment BD, for example, where this is the length of BD. We have to get those to match up. So step 4 is going to be change these two to equal. So BD, not segment BD, equals AD. And DC equals DE. So that's definition of congruent segments. So then step 5, we can start our substitution. Let's do this one. So we can replace AD with BD. So BD plus DC can get replaced with DE. So that can equal AC. We substitute it, so substitution. property of equality. So then step 6, well, BD plus DE is here. BD plus DE is also right here. This one equals BE, this one equals AC. So we can combine them and say AC equals BE using transitive property. So if AC equals the length of BE, then we can say that they're congruent. Definition of congruent segments again. And so finally, we have our side, side, side. Triangle ABC is congruent to triangle BAE. Side, side, side. All done. Piece of cake. Now we got some more shortcuts. First one, side angle side congruence postulate. This says if two sides in the included angle of one triangle are congruent to two sides in the included angle of another triangle, then the two triangles are congruent. The term you need to know that's new is that word included. So two sides in the included angle. Included angle means that angle that's going to be in between those two sides or formed by those two sides. So we'd say angle R is the included angle of segment RS and segment RT. Angle U is the included angle of segment UV and segment UW. So here it says if we have a side angle side situation, so this side, this angle, this side, side angle side, then we have congruent triangles. So it's important that the angle is included. Okay? If the angle is here, well then that's not going to work. Okay? Then it would be angle side side. Okay? Which spells ass. Don't be an ass. That's not the rule. It's SAS. S-A-S. Side angle side. So let's use that. Another proof. Proof triangle MOP is congruent to triangle NOP. Start with the givens, of course. So we have segment MP is congruent to segment NP. And we're going to mark that. So MP and NP. Oh, it's already marked for me. Perfect. Then we have a bisector, it looks like. So start thinking about, what is that bisector going to do? Well, it's bisecting angle MPN. So this is bisecting this angle. So we know these two are the same. Definition of a bisector is what we're using. So angle MPQ is congruent to angle NPQ. Well, we have side angle. We need that other side. Well, they share this one. So we can say that segment QP is congruent to segment QP. That's reflexive property. And so our triangles are congruent, and hopefully you can see we have side, angle, side. So, for some reason, I put that on the wrong side, so let's put that over here. And our side, angle, side would go right there. Piece of cake. I feel like I say that a lot. Alright, and one more for today. This one's hypotenuse leg. So, obviously we're going to need a right triangle, because that's the only time you have a hypotenuse. So if the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So here's your hypotenuse, right? It's the side that's across from your right angle, or you can also say it's the longest side in a right triangle. So hypotenuses are congruent, legs are congruent, therefore triangle ABC is congruent to triangle DEF. So now we have three ways: side, 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 side angle side, and hypotenuse leg. Determine if the triangles are congruent. So these are not proofs, we're just deciding if they're congruent or not. So we look at this one. I see a side and an angle, but you gotta look for stuff that's not marked, like this side in the middle. Now we have side angle side. So ABC is gonna be congruent to triangle DCB. So this is a yes. And if we were going to explain, we would just say side angle side. Next one. We have an angle, a side, and a side. Oh, there's no ASS, like I said before. So then maybe it's hypotenuse leg, but the issue with that is we don't have any right angles. So this one is a no. Can I sneak another example in there at the bottom? Yes, I did. This one, well, we know we share this, right? It's not side, side, side. It's not side angle side because the angle's not included. But we do have right triangles. And we do have a congruent hypotenuse. And we got congruent legs. So this one would be yes because of hypotenuse leg, or HL. Some more examples. Says state the third congruence needed to prove that triangle ABC is congruent to triangle DEF. For some reason these problems always mess people up. It's just understanding what the question is asking. So this says we're going to use side, side, side congruence. So if I look at what's given to me, BC is congruent to EF. So that takes care of these two. AC and DF. So in other words, we're trying to figure out what else do we need. Well, it's side, side, side. We got side, side. We need one more thing. And so that final part's going to be AB and segment DE. So what you would write is segment AB needs to be congruent to segment DE. Using side angle side congruence. So now if I look at this example, AB and DE, and then my angles are angle B and angle E. You can't just pick any old side because it has to go in order. Side, then an angle, then a side. So what side am I missing? Well, it looks like I need this side here to get side angle side. So I'm going to say that I need BC to be congruent to segment EF. So that's what you're doing on these. Stating what's missing in order to get to your congruence. So a lot of proofs. Hopefully they're getting a little tiny bit easier each day. Keep plugging away at them. The more you try, the better you're going to get. Whereas if you sit there and think you can't do it and don't give it a try, you're never going to get any better, and you're not going to get any of these points on tests or quizzes. Okay? So keep trying. I know they're not easy, but if you keep putting your work and effort into it, things will start to turn around. Here's your proof. If you're watching this early, feel free to work on it over the weekend. Probably be happy you did.